Now viewers, well, it turns out I've got a couple more whole current meters yet before I get to my CT ones. And I just realised the CT ones are a lot more difficult than I thought to hook up on this particular setup, because the CT ones have smaller terminal blocks. I can't just stick these wires this big in it. So now if I do it the old school method and just run a direct load through it and go against that meter there to test them. So this one here, I'm going to test next. It's identical to this one, spec-wise, but a single tariff and a slightly later version with a pulse counting circuit in it. 3 phase, 2 2 per kilowatt hour, same as that one. 3 to 125 amps, same as that one. This has a watt hour per pulse. It's got the pulse on it as a board and a little pickup on the bottom of the disc with a pattern on it. 4 wire, 50 Hz, 240 volts. EMR Westinghouse, proprietary limited. Watt hour meter top SDMPH. And yes, a fake digit that doesn't do anything. So it's 69,512, but they specify at 695,120. So that's, yeah, not sure why exactly they would do that. So it counts by tens, and this is a tens anyway. There's no one units in this one. It's just got the 0 there as a fake digit. Didn't think that was allowed, because that would cause estimated readings, but apparently it was they could do that. Issue B CWPL 1990. There you go, 1990. So it says in that circuit board. So this meter was made in 1990. Good quality capacitor. I think it's a Philips electrolytic in there. Looks like it. Could be a Philips or a G Caddy, Italian made capacitor. Good quality stuff too. RCA chip there, and those wires are going to that 2 legs of that chip, and that chip is what deciphers the sensor on the bottom of that disc. Now I think I'm going to have to rewire the pickup bit where the pulse wire goes out. It's been cut off directly, so I'm going to have to find a way I can hook this up and hook up an LED or something to it to get this thing to work in the pulse. It'd be nice. 1995, it was recalibrated, and City Power took over ownership of it, which is part of Power Core, one of the stingiest bloody power companies. You can see how warped that plate is. As you can see, they don't use that port. That terminal block's not used. They drilled 2 holes and stuck this over the top and stuck some glue in there and glued it in. So that's a better way to do it. I can at least wire this up and use it. Should have find out how do I drive this. This has to go to, I think, it should say in here, the pulse. Anyway, find out what that runs. If that runs an LED or what, it'd be nice. Anyway, let's hook it up and give it a test. I'll do some multimeter checks on that, see what that does. Because it doesn't have the LED inside that show you the pulse. It must be an external register. I reckon it's a remote register or something. But we'll try multimeter checks, and then if the voltages seem okay, I'll put an LED in it and see what it does to the LED pulses. I can have the meter down there and an LED up here or something, or next to it, and it will pulse. As you can see, what it does is it looks at those patterns on the bottom of the disc where it's painted. Very nice looking buddy. Very nice looking stuff. Very well made. It's all custom made by the SEC, that circuit board. Anyway, let's hook it up and give it a test. It's got properly rated, good quality electrolytic cap, because it's 125 degrees Celsius rated. I didn't think the electrolytic capacitor rating, temperature ratings can go that high. I thought they only went to 105, but this one's rated at 125 degrees Celsius. That's a quality cap. Time for a test. Got the multimeter on. Hit the clamp meter out and do a test, 30 to 125. Do a 60 amp test here, both of them on the mark. Oops, the tripod there. That'd be alright. Multimeter's on. 60 amps, that's it. The meter's fully loaded. What I'm getting off here, off this pulse, I'm getting 0.0 millivolts. Not much here at all. Not getting much of a voltage on that. Must be some other means, I think. Must be some sort of communication, not voltage. 0.3 volts AC. But on DC, it's in a reverse polarity like that. It's in the millivolt range. Okay. It's working. I'm getting a reading on the multimeter. I turn the multimeter on, you see the reading I'm getting. So that pulsing is working. And it's not an LED, it pulses. There must be some other circuit that signal goes to another circuit. And it deciphers that signal and then gives a pulse. That's interesting. I wonder if I try and hook an LED up to it. I don't think it's going to do anything though. Not at that voltage. But we'll give it a try. If I can find a spare LED in my stash, you can just watch that meter spin while I'm trying to find an LED. I might even try a buzzer. I doubt it though. I doubt it'll work. Where are we here? On the right wire. Multimeter's off. Yeah, it's not done by a buzzer. I think, yeah, it's a signal of some sort. But these meters are both keeping up. Anyway, yep, they're keeping up. Can't have that there anymore. I'll put that back up. Before that bolt falls out. I want to lose all these bolts, even though I've got a heap of spare. Beautiful, that's keeping up quite well. That's the exact same identical dial and number wheels that this meter here has. Yep, perfect, look at that, keeping up. Alright, we can power off. That's a good enough test, I think. I like how the clear case ones have green plastic on the load coils. Only the newer ones do. This other one has white plastic or black plastic on the load coils in there. Right. Fair aircon 0. Unplug safety first before I forget. Otherwise unplug safety first. Alright, let's get that meter a bit of a polish. Not that it really needs it, needs a good light dusting over. But I'd like to know how this has worked. I should ask the meter guy next time how to use those this circuit board here. Must be some other circuit I can make, or some sort of circuit I could use to read the pulses coming out of the terminal block there. Be quite nice to make use of that. Anyway, I could probably polish this thing on camera, it's that clean. Yeah, look at that. A multimeter bit of it. Doesn't need much attention at all. I'll give you a really good look at the inside. So camera off the tripod. It's actually pretty damn clean, this one. A good look in there. Actually, I'll do it while it's running. That'll be better. Get to see it all move while it's running. Makes for a good viewing experience. So I'll plug that back in. I'll turn it back up where it was. That's about 160 volts is about 80 amps. That will take a bit of overload. 80 amps going through that. You can see look at that wheel move. There's little holes you can see there, are anti-creep holes. Get the camera on there. There's 1 hole, 2 hole, 3 hole, 4. There's might be 6 in this disc, I think. Or 1 for where these phases are. The potential coils are. Have a little look up inside. You see this little gear here turning. Too much glare though, unfortunately. Not going to be able to see it. Look at that. Come on, camera. Don't be stupid, please. That's it, camera. There you go. Got the focus. Slowly, slowly turning. I do like the old metal gears in these older ones over the plastic ones. Something's getting warm. And this amplifier 12 volt cable's getting warm. Nothing getting hot down there though. It's laughing at me, eh? Nice and cool. Barely breaking a sweat. It's good. There we are. Watch that little wheel spin. You can see there's these laminated type load wheels are very straight. There's no warping in that whatsoever. Very well made stuff. Alright, we'll switch to variac, or I'll switch the potential off first. That's just with the variac loading it up. Load off. Potential only on. Now there's no load at all going through that meter. You can see the disc is going backwards slightly, very slightly. That movement is called creep. At no load, that's what's called creep. And that's why there's these little holes in the disc which line up in the field where these potential coils are to hold it in place. Otherwise I'll just generate false readings on you. And some other meters I've got, and Raymond Radar 2007 has, on the shaft, there's a little thing that looks like that sticks out, and it lines up with a tab off the potential coil, and that's a magnetic attraction. It holds it in place to stop the disc from creeping. As you can see, we've got a bit of creep there. So it will line itself up to that point where it gets to that little stopper, and it will stop completely. That one there is not moving, so that must have got to the point where it hit the anti-creep mark on the disc and stopped. So that one there's got stopped. That one there is lining itself up. So we'll go backwards until it hits that point and it will stop. There we are, you can see the anti-creep in action in there. Bit of a scuff mark on that, but that's because other stuff's been dropped on it. The rough buggers. Alright, that's all powered off. Unplug safety first. That's it for this one. Thanks for watching.